Hello again, good morning, welcome back. What I want to do this morning is to look at Kirchhoffs Laws. And we're going to look at Kirchhoffs Laws Part 3. Okay, now I've put Part 1 and 2 already on my channel. So please look back at those because it is a continuation from those previous videos. Okay. Now what I want to look at is calculating the current flowing in a circuit when we have two power sources being applied to a given circuit. Okay? And again, always do some background reading on Kirchhoffs. It helps. It enlightens you and makes the knowledge more understandable. Okay? But again, you need to write out what I have put on screen for yourselves. Okay? So let's just go up a little bit. Now I don't want to read this to you because you can read this for yourselves fully. Okay? And you're quite capable of reading, so I don't need to read this out to you. But what it does show is the process that you need to understand in order to evaluate those two power sources. Okay. Now what I've done here is to give you an example, and I've gone through the example in the sense that calculate A, the current in the 4-volt battery, B, the current in the 2-volt battery, and C, the current through the load resistor. Now you cannot do this by guessing, you have to write it out. I cannot emphasize that enough to you. Draw out the diagram. Now I've drawn your diagram here, okay? So please use that. Okay? And I'll just pan back a bit so you get the full diagram in place. Okay? Draw it out so you can understand the concept. Any questions, give me a shout. Now here I've shown you the process as to what we have done in regards to the equations. And remember that you're multiplying out the equation in regards to I1 and I2. So if it says 4I1, then you're going to be multiplying out 4I1 times plus 4I2. So therefore, that multiply that out equation for yourself. See how we have arrived at this solution. Do not just guess. You need to know. Okay? And I've given you some information here in regards to each equation. So all I'm going to do is pan across so you can see that they're linking. Okay? Now I'm going to move up. Now one of the things we also need to know is how to calculate I1, or if we calculate I1 in the first place, how to calculate I2. And you'll see here that you need to do certain things. Be aware of your mathematical signs. Remember that a minus and a minus makes a plus. Okay? And remember, this is now I1 equals 0.857. And again, it's a current, therefore it will be amps. Okay. Now we need to prove our answers, and we need to do that by putting back the results into a given part of the equation. And by doing that, it allows us to arrive at the correct solution when we know both sides are balanced. And here I'm now showing you how we've put that back into the equation. And look back at what you've done. If you've written it out, you'll see exactly where the information came from, and you will not get lost. Just pan it out a bit so you can see it in full. Okay. Now write these out. Do not think you can read it from the screen. It does not work. What you write down, the brain does not forget. And it allows you to apply it anywhere else should you see a similar question. Okay? It means you take that knowledge with you. You're not leaving it behind on the screen. Okay, thank you. Okay, and I think that's where we'll stop now. Okay? And as I've said here, we subtract minus 1.428 from 3.428. We know the answer is correct because it balanced. Okay? And again, please write these out for yourselves to aid your understanding. Okay, have a good morning. Thank you. Bye-bye.